For nearly half a century, the quietest ride on American rails depended on something that should not have worked: wheels built from compressed straw paper. Hundreds of laminated sheets were locked between iron plates, absorbing the vibrations that solid cast-iron wheels hammered into passengers. Tens of thousands rolled beneath Pullman's luxury sleeping cars. Then, in 1915, the government banned them all. The question is not why they failed, it is how they ever worked. Passengers stepping aboard a Pullman sleeping car in the summer of 1870 found themselves in unfamiliar territory. The usual metallic rumble that echoed through every mile of American rail travel seemed to fade away. Instead, a deep hush settled over the plush carpet and polished woodwork as the train gathered speed along the Chicago and Northwestern line. Travelers accustomed to the relentless clatter of cast-iron wheels noticed the difference instantly. Conversations could be held without shouting. The sharp jolts at every rail joint softened to a gentle sway. Newspaper accounts marveled at the transformation, describing a ride so smooth that even the lightest glassware in the dining car barely rattled. One headline called it the quietest journey yet attempted by rail. This was the sensory proof that George Pullman wanted. The secret lay hidden beneath the car: wheels built not from solid iron, but from hundreds of sheets of compressed straw paper locked between iron plates and a steel tire. The dense paper core, pressed under hundreds of tons, acted like a cushion, soaking up shocks and muting the vibrations that once hammered through every Pullman berth. Passengers, some skeptical at first, found themselves lulled by a comfort unknown on previous journeys. The contrast was so stark that railroad executives and engineers crowded into the cars, eager to experience the effect for themselves. For Pullman, this quiet ride was not just a novelty, it was a business advantage, promising restful sleep and a new standard for luxury on the rails. Word spread quickly, and the demand for paper wheels grew as the industry began to recognize the power of silence in shaping the future of passenger travel. Pullman's management moved quickly from curiosity to commitment. Within just a year of the first quiet rides, the Pullman Palace Car Company placed an order for 100 paper wheels, a scale unheard of for an unproven technology in the railroad world. This wasn't a token purchase. It was a signal that Pullman saw something in Allen's invention that went beyond novelty. The order book from 1871, still preserved in company archives, records a deliberate shift in Pullman's procurement. Instead of relying on cast-iron wheels, the company began to phase in the new composite design for its flagship sleeping and dining cars. The business response wasn't limited to buying wheels. To meet Pullman's growing demand, Allen and his partners moved their main plant from Morris, Illinois, to the industrial heart of Pullman's Chicago works. This relocation wasn't just about logistics. It tied the future of the paper wheel directly to the fortunes of America's most ambitious luxury rail brand. Production scaled up, with entire workshops devoted to compressing, curing, and assembling the laminated paper discs. Every wheel that left the new facility bore the weight of Pullman's reputation for comfort and innovation. The numbers told the story: 100 wheels in a single order, a plant uprooted and rebuilt beside Pullman's own shops, and a clear bet that silence and smoothness could become the new currency of the rails. In that moment, paper, usually the stuff of newsprint and packaging, became the backbone of high-end American travel, at least for a time. The industry was watching, and Pullman's wager on comfort over convention set the stage for the next chapter in the story of the paper wheel. Richard Norris Allen was not a typical inventor. Born in 1827, Allen spent years as a locomotive engineer, wrestling with the harsh realities of 19th-century rail travel. The relentless pounding of cast-iron wheels was more than a nuisance. It was a daily obstacle for anyone who valued comfort and quiet. By the late 1860s, Allen found himself drawn to a new possibility. His brother-in-law, L.W. Kimball, operated a straw paper mill in Pittsford, Vermont, churning out cheap, sturdy sheets for the booming newspaper trade. Allen saw potential in the surplus material. In 1867, the two men formed a company with a single, unlikely goal to build a better railroad wheel using paper as its heart. The breakthrough came on May 11, 1869, when Allen and Kimball secured U.S. patent number 89,908. The design called for hundreds of circular straw paper sheets, each glued and stacked, then compressed under 650 tons of pressure. This dense core, after weeks of drying and curing, was sandwiched between thick iron plates, bolted to a cast iron hub, and fitted with a steel tire. The result was a wheel that looked conventional from the outside but hid a radical idea within. Allen's own experience behind the throttle convinced him that the problem was not just noise, it was the way vibrations traveled unchecked through solid metal. The paper core, he believed, could act as a buffer, soaking up shocks before they reached the car and its passengers. The raw material was local and cheap, the process bold, and the promise clear, a quieter, smoother journey, born from a blend of Vermont straw and industrial audacity. At first glance, the idea of using paper inside a railroad wheel seems almost reckless, yet the design was anything but crude. Each wheel began as a stack of nearly 200 circular sheets of straw paper, each one glued and layered with precision. These stacks were pressed by a hydraulic machine exerting 650 tons of force for hours, transforming flimsy sheets into a dense, ivory-hard core. Once cured, the paper disc was sandwiched tightly between two iron plates, each a quarter-inch thick. The assembly was then bolted together, 24 bolts or more depending on the wheel's size, securing the core to a cast iron hub at the center and a steel tire at the rim. This four-part structure was not just a clever use of materials, it was an engineered solution to a specific problem: how to stop vibrations from tearing through a rail car. The iron plates provided strength and rigidity. The paper, compressed to near wood density, acted as a shock absorber, flexing just enough to soak up the sharp impacts from every rail joint. Unlike solid metal, which transmitted each jolt like a bell, the paper core deadened the sound and broke up the chain of vibration before it reached the passenger compartment. The result was a measurable reduction in noise and a smoother ride, especially at speed. By the early 1880s, this approach was not just an experiment, it was an industry standard for luxury travel. Tens of thousands of these wheels rolled out of workshops in New York and Chicago, each one a blend of old-world ironwork and new-world ingenuity. Yet the very structure that made them quiet would later test their limits, as heavier cars and faster trains pushed the composite design to its breaking point. Maintenance crews working the rails in the early 1900s began to notice subtle warning signs beneath the Pullman cars. Wheels that once delivered a soft, quiet ride started to show troubling patterns of wear. As passenger cars grew heavier, the demands on each wheel increased. The layered paper core, so effective at absorbing vibration, faced a new kind of stress. Moisture seeped in through the smallest cracks, swelling the compressed paper and weakening the bonds that held the layers together. Over time, the bolts anchoring the iron plates relaxed and lost their tight grip. This allowed the paper core to separate, a process known as delamination. Once the layers split, the wheel lost its integrity. Small shifts in the assembly led to radial runout, where the wheel no longer spun perfectly true. The result was a wobble that could be felt throughout the car, and in the worst cases, a risk of catastrophic failure. Inspectors documented these issues with growing concern, tracing each step from invisible fatigue to visible danger. The very structure that brought comfort was now a source of risk, forcing engineers and regulators to confront the limits of innovation. In 1915, the Interstate Commerce Commission drew a line under the era of paper wheels. After decades of service on America's most prestigious passenger trains, the commission declared the composite design fundamentally unsafe for continued use. Their ruling came on the heels of mounting incident reports. Wheels that had once promised quiet luxury were now failing under the heavier, faster steel cars of the new century. Inspectors traced a pattern of delamination and structural breakdown, finding that moisture and vibration could work their way deep into the compressed paper core. As the layers separated, the integrity of the wheel collapsed, sometimes with little warning. The Commission's investigation documented not just isolated accidents, but a systemic vulnerability. The very material that once set the standard for comfort had become a liability in a world of growing speed and weight. The order to remove all paper wheels from interstate service forced railroads to retrofit their fleets with all-metal wheels, ending a chapter of engineering optimism shaped by necessity, ingenuity, and the relentless pursuit of a smoother ride. Every composite wheel is a gamble between comfort and strength. Today's engineers face the same dilemma Allen confronted. How far can we push materials to serve human needs before their limits push back? The search for quieter journeys continues, always trading certainty for the promise of something smoother. What do you think?